Did you know that the only letter that does not appear on the periodic table is the letter J? Marhaba! Welcome to another episode of Chemistry is Easy with Mr. Jesse. This tutorial is on Chapter 24, Section 2, Radioactive Decay, and I will cover the following objectives. Discuss electron capture and positron emission, and to apply your knowledge of radioactive decay to write balanced nuclear equations. Recall that atoms can undergo different types of decay to gain stability. Also, nuclei with more than 82 protons, that is, elements having protons greater than 82, are radioactive and decay spontaneously or naturally. The process when atoms are changed into another kind is called transmutation. Now, there are two types of transmutation. The first is the natural transmutation. This occurs in unstable radioactive elements, so basically elements with more than 82 protons. And this is the most common type of transmutation, and this happens most especially during alpha or beta decay. Another type of transmutation is called the artificial transmutation, which occurs when atoms of one element are struck with other particles. So it is possible for elements having a number of protons that is less than 82 to undergo transmutation, and the process of this transmutation is called artificial. So far, you have learned about the types of radioactive decay, which includes alpha decay, beta decay, positron emission, and gamma decay. And in this tutorial, I am going to discuss the last type of radioactive decay, which is electron capture. In electron capture, the nucleus of an atom draws in a surrounding electron and combines with a proton to form a neutron. So here is an example. This is our electron here, and this electron gets drawn by this rubidium-81 atom here. Now this electron combines with the proton of the rubidium atom to form a neutron. So if we are to write the nuclear equation of this example, so the electron is a symbol of E, mass number 0, charge -1, plus the rubidium-81, so mass number is 81, atomic number is 37, and that is Rb, will give us, so 0 plus 81, it would still be 81, and -1 plus 36 will give us 37 will give us 36. That means our element, if we look at it in the periodic table, is krypton. And in this example here, an X-ray photon is produced in the electron capture, so we could write plus X-ray, but this is just unique for this particular example. And here is the summary of radioactive decay processes. So we have here the type of radioactive decay, so alpha, beta, positron emission, electron capture, and gamma emission. On this column, we have particle emitted, change in mass number, and the change in atomic number. Kindly take note of this table. Now let's go to writing nuclear equation. These are some of the questions that came out in last year's system-wide quiz 1 in term 3. So the idea is that to add the missing term to complete this equation. So we just have to look into the atomic the mass number on the reactant side and make sure that it is equal to the mass number on the product side. Also, the atomic number on the reactant side, so the sum of the atomic numbers on the reactant side should also be equal to the sum of the atomic numbers on the product side. So if we are going to look at question 1, the mass number is on the product side is 15, while on the other side it still is 14. So therefore, this particle here should have a mass number of 1. Also, the atomic number on the reactant side is 7, and we already have 7 on the product side. So therefore, the atomic number of this particle here is 0. And a particle that has a mass number of 1 with a charge of 0 is a neutron. So therefore, to complete this equation, the particle that we should be adding is a neutron. Now let's do part B. So in part B, we have to fill in this term here. So again, always go back to the fact that the number or the mass number on the product should be equal to the mass number on the reactant side. So on our product side, the mass number is 18 plus 1, that gives us a 19. But on the reactant side, we have 15. So therefore, this term here should have a mass number of 4. Now moving on the product side, the atomic numbers are 8 and 1, and that gives us a 9. But on the reactant side, we only have a 7, so therefore this particle here should have an atomic number of 2. And a particle that has an atomic number of 4, mass number of 4, and an atomic number of 2 is an alpha particle, which is just a helium atom. Alright, so let's check. We have 15 plus 14, that's equal to 19. And 18 plus 1, that's also equal to 19. We have 7 plus 2, that's equal to 9. And we have 8 plus 1, that is also equal to 9. At this point, I need you to work on C, D, and E and show me your answers in order for me to verify if your answers are correct. This is one of the questions that came out in last year's system-wide quiz for Term 3. Using equations, explain the difference between electron capture and positron emission. So here is the answer. In electron capture, a proton merges with an electron to form a neutron. So let's put that into equation, or let's write an equation about this statement. So a proton, the symbol for a proton is 1, 1, and we have a capital P or a P. So this corresponds to mass number and the atomic number. That's 1, 1. It merges with an electron, so that's plus. The symbol of electron is 0, and we have here negative 1. And this forms a neutron. So you just have to add the mass number. That's 1 plus 0. That's equal to 1. And 1 plus negative 1, that would be 0. So in fact, the symbol for a neutron is this. This is the symbol of our neutron. Moving on, in positron emission, or a proton turns into a neutron by emitting a positron. So a proton, so again the symbol, this is the symbol of proton. It turns into a neutron, and the symbol of neutron is 1, 0, and we have our N, by emitting a positron. The symbol of positron is just the opposite of an electron, so we have 0, and instead of having a negative 1, we will have positive 1. And you could double check. You have 1 plus 0, it's going to give us a mass number of 1, and 0 plus 1 will give us the atomic number of 1. And this is the answer to the question. And that concludes this video tutorial. Once again, always remember, chemistry is easy with Mr. Jesse.